You're here, I'm here, let's go. Good morning, everybody. Welcome to sunny but cold morning in Chicagoland, and welcome to Chem 1105 with your host, me, Dr. White. Oh, thank you, Ruben. I like it too. But anyways, good morning. Now, yesterday, before I talk about yesterday, let me remind you, turn in your labs. They're easy points. Your final grade is determined how many points you get. And remember, I'm now following my syllabus. So you don't want to lose easy points. Please. Thank you. All right. All right. Yesterday, I rushed, really rushed to get through stuff so I could talk about it in the lab. And I promise today we'll go back. I like that, go back, or is this way go back? I guess this way is go back and go over stuff that I rushed through yesterday. So let's do that. Now, we're talking about how do chemists quantitatively describe solutions. And the first two I'll go over again because they're important for your daily life, the rest of your life. These will help you out. And one is percent concentration. Remember, switches off on this slide, and percent concentration is the percent of by mass, meaning weight, and you calculate that number by percent mass of solute divided by mass of solution times 100. And the mass of the solution is the mass of the solute and solvent. Now, the higher the percent mass means there's more solute present in that solution. Now, what does this mean to your daily life? It means when you buy things, if you look at the label and they say a percent of certain something, as I mentioned yesterday with insect repellent and also antimicrobial or mold, what would be the right term, reduction or anti-mold compound or products, the higher the key ingredient, the higher the percent by mass, in my personal opinion, the more effective it is, which in most cases that's true. So that's percent mass. Now, another one is percent volume. And that's, again, switches off for this slide, but that's volume of solute divided by the volume of the solution. And the volume of the solution is obviously the volume of the solute plus the volume of the solvent. Remember, solvent, component of a solution present in the greatest amount, and then the other components are called solutes. And here again, the higher the number, the more solute that's present. Now, I talked about this yesterday briefly, but I'll bring it up again now because I think it's interesting. And that is when we talk about alcohol, and I'm not in any way implying anybody should go out and buy, especially if you're underage, the good stuff, like Grey Goose vodka, Absolute vodka, or if you want to save money and it's really good, the Costco French vodka with the red glass at the bottom of the bottle. But anyways, and there are other things. And the way alcohol, there's two ways. One is by percent. I'm not sure if that percent is volume or mass. Let me run down. No, I'm not going to check the bottle. But anyways, the other old way, and still on the bottle, is proof. And I thought I'd mention proof originally was started in England. I looked it up this morning. I cheat. No, I didn't cheat. I looked it up. Where was there a certain amount of alcohol, and they put some gunpowder in there. And if there was too much water, you couldn't light it. In other words, it wouldn't take off. have combustion, because the water, as you know, water puts out combustion, fire. Firemen use it all the time. Now, that evolved into proof, a percentage, and in the United States, take proof divided by 2, and you will get the percent alcohol. So something's 90 proof, it's only 45% alcohol. Now, don't tell anybody I'm teaching you some good stuff. But first, how do you really measure proof? With a hydrometer. And a hydrometer is really some lead shot in air and a gauge, and it works by density. The more alcohol, the different the density of the solution will be, which will have this hydrometer move up and down. I had one company, I saw them use a hydrometer somewhat till I found a better way, more accurate way of measuring what they were measuring with the hydrometer. And guess what? You know about density, and this helps you determine proof. And that's in alcohol. But the most important way of measuring concentration is molarity. And as I mentioned yesterday, molarity is a ratio of the given number of moles of solute per liter of solution. Oops, the dreaded dot virus got me again. Actually, that one I want to keep. All right. It's this one I don't want. That's not what I want to do. Never mind. Anyways, you should know molarity is moles of solute per 1 liter of solution. You see, I even put it on the slide. Very important. Know this. Now, in the lab and in real world, we deal with smaller amounts, and that's milliliters. Remember, 1 liter equals 1,000 milliliters. Therefore, molarity, moles per liter, is also moles per 1,000 milliliters. Both liter and milliliters are exact numbers. That's part of the definition. So where does this take us? A number of important molarity questions. But before I go through these questions, let's go through some basics. What does the following mean? 3 points each. And I'll do this one. Remember, capital M is the abbreviation for molarity. Oops, I keep on doing what I shouldn't do, and that's using cursive when I should print for this class. All right, you should know. Hold on. Time to bring out the big guns. You should know molarity, which is shown by capital M, is moles of solute per 1,000 milliliters of solution. And because I've cut down on memorization in my general chemistry courses, I would like you to take time to look at important information. And you'll see right here for test 3, which is coming up, I think, in about 2 weeks or so, maybe 3. No, I think it's 2 weeks. That molarity is moles of solute per 1,000 milliliters. In the past, students had to memorize this. Now you're given it, but you still have to know how to use that. So let's go back. And what does this mean? I'll do this one. What it means is 2.49. The capital M tells me molarity, which is this, moles of H2SO4, which is called sulfuric acid, and in the United States, well, let me finish this, per 1,000 milliliters. I did it again. There we go. And I should mention sulfuric acid, H2SO4, is probably the most widely, I don't know, widely is not, is the chemical that they make the most pounds per year in the United States, if not the world. It's used in everything, including your car battery. If you have a car, or if you don't have a car, your parents or friends' car battery. And if your friends and parents don't have it, next time you're walking down the street, any car that's moving along has that in the battery. All right, your turn. What does this mean? Hint. All right, let's do it. What does this mean? When you see a capital M, that means molarity. And therefore, what does this mean? Molarity is moles of solute. In this case, the solute is KOH, which is called potassium hydroxide. The old name used to be potash, but it's the IUPAC. IUPAC is the official name, is potassium hydroxide. And what that means is, oops, there's 8.776 moles KOH, potassium hydroxide, per 1,000 milliliters. Oh, I didn't write it out. I'm starting to learn printing again. Now, let's do another one. And now the question will be, I should make this A. What does this mean and what is the solvent? Well, here's a capital M, that's molarity. So immediately I can say 1.05 times 10 to the third moles of sodium chloride per 1,000 milliliters. Now, what's the solvent? And this tells us what is the solvent. Bracket A, Q, close bracket, is shorthand for aqueous. Aqueous means water, and that means water is the solvent. And now it's your turn. What does this mean, and what is the solvent? I'll give you 8.7 seconds more. Go. Bonus time. Looking at my watch down here. Time's up. What does this mean? As soon as you see the capital M between a number and a chemical formula, that's molarity. And what does this mean? 7.995 times 10 to the minus 1. Remember, molarity is moles of solute, in this case, sodium sulfate, Na2SO4 per 1,000 milliliters. And this tells us that water is the solvent. All right, now let's look at some important questions concerning molarity. All right, quick, I haven't done it all morning, so I better do it. Thumbs up, people. Do you see the problem? 5 points each, or 5 points. Thank you, Ruben. All right, let's go through it. I'll do this one. I'm gonna let you have fun with it. How many moles of KCl, potassium chloride, are in 546.8 milliliters of a 1.015 capital M KCl solution? So what are we being asked to find? Moles, potassium chloride, KCl. What are we given? We have 546.8 milliliters of solution, and we have this number. And as soon as I see the capital M, I know that's molarity. And what does that mean? I'm going to give you 10 seconds to figure out what you should write there. Go. I think that's about 10 seconds. And the answer is molarity, moles per 1,000 milliliters. So that'd be 1.015 moles of potassium chloride, KCl, per 1,000 milliliters. So this is really the only number we have to start with. So I will. Did it again. I'm going to have to teach you people how to read cursive for milliliters. So I keep on writing it that way. All right, we have this and we have a ratio. What units do we want our answer to be in? Moles of KCl. And how do we proceed? It's time to use your good buddy, your good friend, unit analysis. I love that. And I also love unit analysis. Whatever we're trying to get to units goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Let the paper do your thinking, write them in. Trust me, it's helped me with all the tests I've taken over my academic career. And we're trying to get rid of milliliters. So that goes underneath. Where do we get these numbers? From here, knowing that this really means this. So it'd be 1.015 moles of KCl per 1,000 milliliters. If you notice, this is, 4 significant figures. This is 4 significant figures. And this 1,000 is an exact number. So our answer should have, I'm out of my rut, not 3, but 4 significant figures. Remember, when you do multiplication division, the number you get should have the same number of significant figures as the number you're multiplying or dividing that has the lowest number of significant figures. Time to use the calculator. If you're not sure how to use your calculator, and you'll need it for test number 3, please come to my office hour tonight. And my calculator gives me this number. And I'll let you round that off to 4 significant figures. Then I will. And the answer is keep the 5, keep the 5, keep the 5, and keep the 0. That's 1, 2, 3, 4 significant figures. Use the next number, 0, to round off. That's 4 or less, so drop it. So the answer would be 5.550 times 10 to the minus 1 moles KCl. All right, your turn. I'll give you some time. If you don't have your calculator, just set it up right here. Find out what are you being asked to find, what are you given, and then set up the equation if you can using your good buddy, your good friend, unit analysis. It's been mine for many decades. Oh, I forgot to say ready, set, go. And don't forget, Friday is National Turn on Your Webcam for Dr. White Day. If I give you a piece of candy, would you turn on your webcam? It's Halloween, remember that. Again, you should be working on this problem. Oh, when you're done, give me a thumbs up. Give you another 30 seconds. So start working, please. Oh, looks like a lot of you don't like or can't use your thumbs up, but you can vote. All right, I think everybody's done. Let me get to work. So the first question is, what are you being asked to find? And the answer to that is right here. How many moles of HCl? What are you given? Well, we're given this, how many milliliters of solution? And we're given this right here. And the question is, how do you proceed? Well, first you look at this and say, ooh, capital M with a number and a formula on either side, that's molarity. And what does this mean? It means 4.62 moles of HCl, hydrochloric acid, per 1,000 milliliters. Oh, I did it again. All right, everybody, it's time for me to teach you how to recursive. ML equals this. This is an M, this is an L. ML equals this. This is an M, this is an L. On test, I'll print it out. Obviously, you can read it. But anyways, this is the only number we have to begin with. So we will. Remember, ML, ML, like right here. And if I had a ratio, what do I want to get to? Well, we figured that out right here. Moles of HCl, hydrochloric acid. And later in the semester, I'll teach you about hydrochloric acid and other acids and bases too. You don't know what those mean, you will. Next chapter, I think. So anyways, using your good buddy, your good friend, unit analysis, whatever we're trying to get to goes on top. Whatever we're trying to get rid of goes underneath. And it's important when you're taking a test, write it. Don't try and keep this in your head. So milliliters divided by milliliters cancel out because A divided by A equals 1. Where do I get these numbers? Where do I get a relationship of moles of HCl and milliliters? Right here. We have 4.62 moles of HCl per 1,000 milliliters. And this is 3 significant figures. Oh, look, 3 significant figures, and 1,000 is an exact number. So my answer, lowest of the 2, 3 significant 3, should be 3 significant figures. And now I can pick up my calculator, clear it, and my calculator gives me this number. 1.539 times 10 to the 0 power. Remember, 10 to the 0 equals 1. If you want to write it with 10 to the 0 on a test, that's fine for me. If you don't want to put it there, that will work as long as it's 10 to the 0. So now we look at how do you round this off to 3 significant figures. I'll let you do that. Oops, I wrote this wrong. Hang in there. Writing error. Now, what just happened to me, I read the screen wrong from my calculator. And this is important on test 3 and all my tests. Show your work. Because if you make a mistake like that, what I just did, and wrote down the wrong number and nothing else, I'll give you a 0. If you show your work and you make that, I'll only take off 1 point. All right, let's round this off to 3 significant figures. Keep the 1, keep the 5, keep the 9. Use the 3 to round off. That's 4 or less. I drop that. So it's 1.59 or 1.59 times 10 to the 0. Remember, 10 to the 0 is 1, so you can put it down or you don't have to. And this is moles HCl. Now, in a chemistry lab and even a chemical plant, it's good to make what we call stock solutions. Remember, this is milliliters. And the question is, how many grams of sodium chloride, NaCl, are needed to make 523 milliliters of an 8.62 capital M NaCl solution? So what are we being asked to find? How many grams of sodium chloride? Remember, please pass the nickel. What are we given? 523 milliliters of solution, and we're given this right here. And as soon as I see capital M and one side a number, the other a formula, I know that's molarity. And before I go any further, I'll say, what does that mean? And I'll write it down. Now, there is no way I can go from milliliters of a solution to grams. There isn't. What you need is 2 steps. In the past, you'd have to memorize this, but good news, no more, because if we look at important information, test number 3, molarity 2-step problems. And step 1, whatever we have in milliliters, we'll convert to moles. Step 2, whatever we have in moles, now we'll convert to grams. And let's do that. So step 1, whatever we have in milliliters, in this case, 523 milliliters, we want to convert to moles. And what moles? Well, we're talking about sodium chloride. So let's do that. And now you use your good buddy, your good friend, unit analysis, whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. And where do you get those numbers that go here and here? Well, first of all, I'm going to do something that I should do and write in those units. Don't keep it in your head. Let us put it on the paper. Where do we get a relationship between moles of NaCl and milliliters? Right here, the molarity. When written like that, is 8.62 moles of NaCl per 1,000 milliliters. Oops, I already have the milliliters there. Oh no, I've got milliliters on the brain. But anyways, milliliters divided by milliliters cancel out, because anything divided by itself equals the number 1, meaning it's gone, it cancels out. And notice this is 3 significant, oh, he's in his rut again. 3 significant and exact number. So I should have, yep, you're right, 3 significant figures for my answer. And now I will clear my calculator. Let me do it again. I'm going to tell you about a mistake I just made, which I make once in a while, and you might do the same thing. And my calculator gives me this number. And I'll let you round this off to 3 significant figures. Time's up. Keep the 4, keep the 5, keep the 0. Use the 8 to round off. That's 4 or higher. This and everything else, because you're past the decimal. I'll drop the number in front. I'll increase by 1. And you don't have to write it, but I will. 10 to the 0 moles of sodium chloride. Now, am I done? No. I'm trying to get to grams of sodium chloride. So now I'll need step 2. And step 2, which you can look at, important information in case you forgot, but I didn't, so I don't have to look. You want to go moles to grams. And therefore, we have 4.51 times 10 to the 0 moles of sodium chloride. And we want to get to grams of sodium chloride. And once again, we'll use our good buddy, our good friend, unit analysis. If I go here, whatever I'm trying to get to goes on top of that ratio. Whatever I'm trying to get rid of goes underneath. And here we have grams of sodium chloride. Here we have moles of sodium chloride. And where do I get a relationship of grams of a compound to moles of a compound? Ooh, good question. Thank you. Well, in case you forgot from test 2, you can look at important information, test number 3. And it says right here, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of the compound is the sum of all atomic weights in that compound. So we need the atomic weights of sodium and chlorine. So let's go over here. And I'm going to give you 20 seconds to figure out the 3 significant figures. What's the atomic weights of sodium and chlorine? Go. This way I can sneak some tea. All right, so for sodium, Na, 22.989 rounds off to 23.0. For chlorine, 35.453 rounds off to 35.5. So for the molecular weight of sodium chloride, I have 1 sodium, 1 chlorine. Here are the atomic weights. It adds up to 58.5. Remember, you get the same number of significant figures to the right of the decimal point as the number that has the fewest significant figures to the right of the decimal point. This is 1, this is 1, I've got 1, I'm done. 1 mole of a compound equals its molecular weight in grams. And now notice moles of sodium chloride divided by moles of sodium chloride become the number 1. And I can pick up my calculator and do my calculation. And my calculator gives me this number. And how many significant figures should our final answer have? I'm going to let you figure that out. And also, why don't you figure out what number goes here, right here, then I'll do it. Time's up. This is 3 significant figures. Oh, he's in his rut again. 3 significant figures. 1 is an exact number, doesn't play a role. So you should round this off to 3 significant figures. Keep 2, keep the 6, keep the 3. Ooh, got an 8 again. As 4, 5 or higher, drop these, increases by 1. And the correct answer is 2.64 times 10 squared grams of sodium chloride. And that's how you do it. And remember, a friendly reminder from your friendly neighborhood chemist, it's 10 points. Yes, 10 points. Does everybody get the hint? All right. Let's go back and look at something I went through the other day, and that's like dissolves like. And when we talk about that, they're polar substances and non-polar substances. And the most polar substance in the universe is water. Other ones are salts, like sodium chloride is an example, alcohols, such as ethanol or 2-propanol, the alcohol, isopropyl alcohol and rubbing alcohol. And also, you don't know about it, so I'll rewrite it. One type of alcohol that doesn't get you inebriated is sugar. That's a polar compound. Now, nonpolar would be gasoline, vegetable oil, corn oil, soybean oil, regular vegetable oil, canola oil. Those are all nonpolar. And Vaseline and baby oil. And later on, we'll talk about dirt and grease. And like dissolves like tells you polar things are soluble in polar things, and nonpolar things are soluble in nonpolar things. And if you take, say, vegetable oil and salt, it's not going to be soluble. If you take water and baby oil or Vaseline, it's not going to be soluble. And that's why they use Vaseline and baby oil on babies in their back end and other parts to keep water off the babies so they don't get irritated. And with that pleasant thought, I'm going to say, I'm done. I bet you never thought I'd talk about babies' rear ends. I did. Ooh. But anyways, with that, remember tonight, I have my office hour from 5 to 6:15. If you have any questions, stop by. Also, remember on Friday, I'm going through chapter 6, problem set, do them. And with that, I'm going to say, Gang gesund. Goodbye.